So today we starting chapter 7, transformations, and today we will look specifically into the translations, and we will learn mapping, so-called mapping notation, to use with the transformation. So if we have, so our learning intention is translations. So if we have point on the Cartesian plane we have point, let's say 3, 2, and we translate it to the point, let's say 6, 5. 6, 7. To point 6, 7. So what happens? X coordinate change to 6 from 3, 2 change to 7. So we have 3 to 6, 2 to 7. How we did it? So we have 3 plus 3 and 2 plus 5. We translate the point. So we will use x dash and y dash as a new coordinates after the transformation. New coordinates. X and y will be old coordinates. So x and y, that was coordinates before transformation, x dash y dash after. So we have that in this case, how we get x dash from x?
X plus 3.
X plus 3. Y dash equals y plus 5. So that is horizontal translation, this is vertical translation. We translated point 3 to the right and 5 up. And now, when we will be doing transformation, what you need to do, you need to rearrange those formulas to make the new coordinates as a subject. So what x dash will be here, from here? If we rearrange this, x dash, x, we find that, and again the dust disappeared here. X will be equal x dash minus 3. Y equal y dash minus 5. We always, yes?
How do we know it's not x plus 3? Or how do we know it's x plus 3, not like 2x? Let's just say.
No, we consider this particular example.
Yeah, but in this example, x dash could be 2x.
We said we translated point.
Okay.
We just moved it.
But
Then we will learn, I understand what you're saying, that it can be, we can get to the same point doing multiplying x by 2,
yeah.
and we will be looking when we will have combinations of the transformation, when there happens translation, dilation, reflections. We'll have a look into that
So
later on.
for
Today we're doing only translation. So we move it up, right, or left down, or left up. Today we're doing just that.
Okay.
So we know by fact that it is, because initially I said let's translate this point to the new point, point A to new point A dash.
Yeah.
Key to solve all problems with the transformations is write how we get a new coordinate from the old, and then rearrange it, make the old coordinate as a subject, and make all coordinates as a subject. And let's see how we apply if we have some function. For example, we have y equal let's say 1 on x. Let's say we have function 1 on x. And we do next transformation. We move it, let's say, to right, and we do 5 or 3 down. So we translate, we have function y equals 1 on x. We translate it 2 to the right and 3 down. And let's find what will be the new equation of the graph. So what we do, we write so what will be the new x coordinate? What we do with the x? We move it 2 to the right. So we added 2, we move it 2 to the right. What happens with the y? What we did to the old coordinate? So y minus 3. Let's rearrange this to make old coordinates as the subject. So we have x equal x dash minus 2, y equal y dash plus 3. And let's substitute next step. After we have rearranged, we got old coordinates in terms of the new coordinates. We substitute them, because they're the old coordinates. We substitute them into here. We get y dash plus 3. Instead of y equal y dash plus 3. So we substitute, instead of y, we substitute y plus 3. Equal, instead of x, we substitute x minus 2. X dash minus 2. And that is the new equation. That is a new equation. What we do on the next, the final step, we just drop dashes. And because we want to have y by itself, so it becomes y equal 1 on x minus 2 minus 3. So as we've learned before, when we were looking just into the hyperbolas, we already knew that when we have x minus 2, it translation which direction? To the right, not to the left, 2 to the right. And with the y, it's 3 down. But how we get it? We get it from 3 down, minus 3. Now, let's do another function. Let's do another function. For example, for example, let's consider y equal x squared. Y equal x squared minus 3x minus minus 6. And let's translate this parabola. Tell me where you want to translate it.
3 up.
3 up and 2 down. No, 2 not 2 down.
2 to the left.
And 2 to the left. And 2 to the left. So we write y dash equals y plus 3. We're moving 3 up. X will be equal x dash, x dash equal x minus 2. We're moving 2 to the left, we're making x smaller. Next step, we rearrange those transfer. This is called mapping, we're doing mapping. It's called mapping notation. So y equal y dash minus 3 x equal x dash plus 2. And let's substitute those expressions into our equation. So instead of y, we write y dash minus 3 equal x plus 2 squared minus 3 times x plus 2
Should it be x dash?
x dash plus 2, we'll drop them, and minus 6. What we need to do now to get final answer? Expand and collect like terms. And I'm dropping dashes. Y minus 3 equal x squared plus 4x plus 4 minus 3x minus 6 minus 6. Y will be equal finally x squared plus x squared plus x plus 4 minus 12 minus 8 plus 3 minus 5. So if we move this parabola 3 up and 2 to the left, it turns into this parabola. It turns into this. Let's check how we can check that we're correct. Turning, let's have a look onto the turning point. What was turning point of this parabola? What will be x-coordinate of turning point? It will be negative b on 2, 8. So turning point was 3 on 2. And what will be y-coordinate? Substituting 3 on 2 will be 9 on 4, minus 9 on 2 will be minus 9 on 4. Minus 6 will be negative 33 on 4. Check if I'm correct. Negative 33 on 4. Now turning point will be of this. New turning point will be will be negative b over 2a minus 1/2 minus 1/2, and we substitute to minus b on 2a. We see how weights move just to check that our process lead to right result. And we will substitute negative 1 on 2, we get 1/4 minus 1/2, negative 1/4 minus 5, negative 21 on 4. Now let's see, we were at 3 on 2, now we're at negative 1 on 2. What happens? 2 to the left. Yes, we were correct. And why? We were at negative 33 on 4, now we're at negative 21 on 4.
Because negative 12 on 4.
We moved up by 12 on 4, which is 3.
Yeah.
Yes. So this is method. So always when you're doing transformations, first today we'll look only into translations. Next lesson we will look into dilation, reflection, and next week we'll mix them all together. You start from writing new coordinates in terms of the old coordinates, rearrange, make old coordinate as a subject, and substitute them into the given initial function. Make sense?
Yeah.
Yeah.
Like, subscribe, and donate to help fight terrorist countries and organizations like Russia, Iran, Houthis, and so on. Support Ukraine and Israel.